Good evening, everyone. We'll start the session. This is Vikram again. So today we'll continue yesterday's session. Okay. So yesterday we tried to understand a few basics about so the concepts that we have learned earlier, right? So we tried to do some programs, basic programs, and all. Okay. So what we will do is we will try to cover or we will try to continue the same thing today as well. Okay. So today what we will do, we will try to understand the basics of or try to do basics on arrays. Okay. Excuse me, I still could not improve my handwriting with pen. So I'll try to write it a little slow so that you can understand. Can you all hear me? If anyone is not able to hear me, please log out and log in again. So from couple of days, I think for yesterday also we had some issues. Some of you are not able to hear. So please log out and log in. So then you should be able to hear me clearly. Okay. Yeah. So what we will do is we will try to understand, try to do some programming on arrays. Okay. Arrays. So today we will concentrate on one-dimensional arrays and try to do some programs. Okay, some programs. Okay, some programs we will try to do with single-dimensional arrays. Okay, single-dimensional arrays, and at the last we will try to do one sorting program. Okay, we'll try to do one sorting program, accepting some elements from the command line. Okay, so let's get started. Okay, so okay, how many of you can hear me? How many of you can hear me? Can you all, am I audible to everyone? Can you please confirm? Okay, Shravanti, Kavita. So please check whether you are mute or something like that. Yeah, you, Mama. So please try to log out and log in again. Okay, so that that might resolve your issue. Okay, that might resolve your issues. So let's just wait for a couple of minutes. So I think around 4 or 5 people are left and they are joining again. Okay, let me know if you can, if all of you can hear me, so that okay, I assume everyone can hear me. So single dimensional arrays, how the syntax for declaring a single dimensional array is, say for example, data type, some variable name. So we prefer to give the square bracket, which indicates it is an integer array, single dimensional integer array. Okay, we specify an identifier, some array, my array is equal to, we know that new is an operator which allocates memory to your array, and int, and we specify the length here, number of elements in an array, elements in an array. Okay, make sure that this is the same data type that is here, because we are declaring an array of integer type. Okay, let us try to create a simple integer array. Int, same thing. Okay, my array new int of, say I will take only 3 elements. Okay, so what it says is I can store 3 integers in my array. Okay, I can store 3 integers in my array. Okay, so how can we know that the array index, so you can access elements in an array using what are called as indexes, right? So index always starts with 0 in Java. Okay, we'll not bother about what is the index in other languages. We will just concentrate on Java. So index always starts with 0. Index always starts with 0. Okay, so now I have declared an array and allocated a memory to this particular array. Okay, this is an integer. So integer takes how many bytes or bits? 4 bytes. So 3 is 12. Okay, 12 bytes are allocated in your RAM, in your physical memory. Okay, now I want to assign, and there are only 3 elements you can assign, right? So what I will do, I will assign individual elements. Okay, so I will say 2 is equal to 6. Okay, my array 1 is equal to 5. Okay, my array 0 is equal to 4. Right? Okay, so individually I am allocating. So the order doesn't matter. So in whichever the order you want to allocate, individually you can allocate those values to those elements. Okay, I want to print the elements. Okay, print line. First element. Okay, what I will do? My array of 0. Okay, I'm printing the elements individually. Okay, what I will do? Second element, because it starts with 0. The index starts with 0. That's right. Okay, I will run this. Okay, I can see this values. Okay, so the first element, this is I mean your index will be associated or related to your number, whatever the value that you store. Okay, index is related to your number. So whichever the way it again, like whatever the order in which you want to assign, you can go ahead and assign, but the index matters. Okay, so in 0th index always there will be 4. In first index the value will be 5. Second index the value will be 6. Okay, second index the value will be 6. So we have seen one particular property of an array. Okay, one particular property of an array which gives the number of elements stored in that particular array. Okay, number of elements that is stored in that particular array. Okay, so how do you do that one? What is the property? What is the property? Anyone remembers? Okay, number of elements. Length is the property. Okay, so you can call on any array, you can call dot length. Okay, any array you can call Yahoo. Yeah, correct. So any array you can say that particular array identifier that you specified for that array, right? Array dot length, that always gives the number of elements that is stored in that particular array. Okay, we will try to modify this. Sorry. And then array elements, we will do array elements. Okay, Okay, so why did it come down? Okay, so we'll try to print it. So array elements, what are the values that we have entered? Okay, 0, 1, and second index. Okay, so number of elements in the array, 3. Okay, so this is the size that we specify here for this array elements. Okay, let us try to do what we did in the last class. Okay, try to accept the elements from the command prompt or from the input device, that is keyboard. Okay, so what we will do, we will say or one more thing is there. So this is one way of assigning values. Okay, this is one way of assigning values. So what we have done here, we have done, or we have allocated values to individual index. Okay, so while declaring itself, we have seen a syntax to assign a value, right? To assign values or which are the number of elements that you want, you can assign it. Okay, say for example int. Okay, so this is the preferred way. As soon as you specify the data type, mention the or if you can call it as the dimension, just mention this one. So open and square bracket. Okay, that says as soon as the person sees this, he will say like, okay, this is an array of type integer. Okay, that is why this is the preferred way. Okay, so say int my int, okay, is equal to new int of, okay, I'm declaring and initializing it. Okay, it doesn't have anything as of now. What I will do, 2, 4, 5, 7. Okay, so now I will try to print the length, because we don't know, we have just entered the numbers, right? So I will try to print the length. I'll try to print the length. Okay, sorry. Okay, this is another way. Okay, so let us see in what order these elements are assigned. Okay, let us try to print. I'm purposely writing system.out.print ln or print line. Okay, I want all of you to try writing this one. Okay, yeah, Hari, but Hari has mentioned this one, this syntax. Okay, so the problem with that syntax is like you have to specify the size when you declare like that. When you are initializing, you have to put it inside your flower brackets like this. Okay, like this. So let us see the order in which or the index of each and every element. Okay, at 0th index. Okay, zero. Okay, so it says 0th element is 3. That means this is the one. So obviously this should be 1, this should be 2, this should be 3, and this should be 4. Right? So the order in which you give the elements, the index follows like this is the first element, that is 0th index, second, third element, fourth, fifth, sixth. Okay, 4, 5. Okay, 0, 1, 2, 3, 4. Okay, that is the order in which the index is given to each element. Okay, so what we did, excuse me, we have assigned values to individual array elements using index here. That is one way, and while declaring itself, we have initialized the array. This is the second way. Yes, correct, Ari. Yeah. So that is the second one, and let us try to accept the input from the command prompt. Okay. So or the keyboard print line. Okay. So I will for our information I will tell enter the number of elements in an array. Okay, enter the number of elements in an array. Okay, what I will do, I will use a class. Please let me know if you can, if you can't hear me, or if I am not audible. Okay, scanner input is equal to new scanner of system.in. Okay, this is a class in java.util package. So we have to import that class. So that is done using your import command. Okay, that is done using your import command. Seems like some syntax error. So as soon as you declare that variable, better to close it. Okay, otherwise it will keep showing leakage, memory leak like that. Okay, so now what I will do, I will declare int num of array elements. It says number of array elements. Okay, it is always recommended to give proper the identifier a brief name. Okay, so that we can when someone else or the person who is trying to go through the code, right, will be able to understand, so that he can understand what is going on in that particular program. Okay, so what I will do, I will do next int. Okay, so this is one thing. Okay, what it does, whatever the integer that you enter from your keyboard, that will be assigned to number of elements. So what we are doing here, we are trying to first ask the user how many elements you want to store in the array. Okay, then this after this only we will okay, let us declare later. Okay, after this number of elements we got, we will try to declare int. I'm just giving for simplicity I am using only integer data type. Okay, int data type. You can use any other data type also. Okay, as I showed in yesterday's class. Okay, int what is that? Keyboard int. Okay, is equal to new int of what will be the length? The length we have accepted from the keyboard. Okay, so now what we have to do, we have to accept individual elements, right? How do we accept individual elements? We know, right? We know for loop, right? We know for loop. So what we can do is we can use for loop on counter, initialize it. Counter should be less than, counter should be less than what? Counter should be less than, let us use this, let us factor this one. Okay, dot length. Okay, it should be less than the length of element that is specified for keyboard ints. Okay, because we are starting with 0. Okay, so the index of array element starts with 0. Because of that we start with 0. Okay, so you can come up with the logic. Even if you give 1 here, you can modify this particular condition accordingly, so that you can read elements and assign it to proper index. Okay, counter plus plus. Okay, then what I have to do, I have to assign whatever the value that I accept from next int. Okay, next int to respective array element, right? So array element, what is the array element? So what is the identifier of the array? Int. What I will do, I will give counter. Okay, counter. So next what I will do, input dot next int. So anyone has any questions regarding these statements, whatever I have mentioned here? Please let me know. Okay. If you have any questions, please let me know. Okay, if you have any questions, please let me know. What I'm doing here. Okay, so let me try to explain this particular thing. So let me take this one here, this particular logic. Okay. Okay, so what I will do here is I will paste that here. Sorry. Paste that here. Okay. So it is not properly indented. So let us, that's okay. Okay. So we are trying to explain this. So we know the array is, sorry. We know that the array is keyboard ints and the number of elements is we can access using this length member of the array. Okay, array is implemented as object in Java. All right, that's what we know. So this is the counter. We have initialized it to 0 and we'll increment. Here we are incrementing the counter so that we accept value for individual index. Index starts with 0. That's why we have initialized it, the counter to 0. It is not necessary that you have to have counters. You need to have counter initialized to 0. Okay, you can initialize it to 1, and accordingly you can manipulate this particular statement inside your for loop. Okay, this is your for loop block of code. Okay, so what I'm doing. So how many elements are there? Say for example, I give input as 3. I want to accept 3 input. Okay, so this is similar to keyboard. I'll just mention KB of 0. With this logic, I'm explaining with this logic. Input is, say I'll give 1. Okay, KB of 1 is equal to 2. KB of 2 is equal to 3. Okay, this is what is happening with each. This for loop, we know that it executes a set of or block of code n number of times. Okay, that n number of times we specify. That n number of times we specify. Okay. The n number of times we specify using sorry, I erased it. Okay, then number of number of elements we have accepted using our keyboard, right? Okay, so using our keyboard we have accepted it. So for each individual element, we are this particular statement gets executed. Okay, this particular statement for each. So how many number of times? This is the number of times it executes. Starting from 0, it should be less than 0. But if you say less than or equal to, one element will be more. So if I say 3 elements, I want 3 elements, we will be accepting 4 elements. Okay, so you should be very careful with this particular operator that you use, this particular condition in general. Okay, in general, this particular condition, you should be very careful. So what exactly happens? For the first loop, okay, first loop counter will be 0. When C is equal to 0, Ki, let me mention it as keyboard ints as I 0, because this is 0 because counter is 0. That is our C is 0 is equal to whatever the value that we enter from our keyboard. Okay, then counter is incremented with this, so C becomes 1. Okay, now this particular condition gets executed. So is it now I have given length as 3. Okay, the condition, the test condition is C less than 3? Yes. So it executes this statement again. Ki of 1 is equal to 2. Assume this is what I am entering from keyboard. Okay, now C is incremented once, so it becomes 2. Okay, now again what I am doing is so I'll continue with wherever we stopped. So what exactly happens is, really sorry. Okay, so what exactly, I'll continue from the last statement. Okay, so C is equal to 2. Now what I'm telling, this particular condition gets executed. Is E or is 2 less than 3? Answer is yes. So it is true. So this condition gets executed again. Ki of 2 is equal to, say assume I'll enter 3. Okay, so I have entered 1, 2, 3 values in my array. So all the 3 values for this individual index, right? Using this counter, we are making it. Okay, so now what we have, Ki of 0 is 1, 1 is 2, 2 is 3. Okay, so now what happens? C becomes 3. C is nothing but our counter here. Okay, C becomes 3. Now the condition is, test condition is 3, that is our C, is less than 3. No, wrong. 3 is equal to 3, not less than or greater than. So this condition becomes false. So we will come out of this particular for loop. Okay, we'll come out of that particular for loop. We'll come out of this particular for loop, and then the next statement after the for loop will get executed. Okay, that is what is happening with our this particular statement, whichever I have highlighted here. So let me go back here. Okay, so with this particular I mean, whatever the statements that I have highlighted, that is what happens, which I have explained in the slides. Okay, so after this we will have array elements set properly. Okay, let us try to print the array elements. Okay, what I will do, again, to read individual array elements, we have to use for loop again. Okay, within the block, so let us copy paste the same thing, because we are using the same array, right? So let us use this, and then what I will do just system.out.print. Okay, so here what is the difference between this print and this print line? Print line is, it prints and goes to the next line. That means it at the end of the string, it includes one /n, which is nothing but new line. It goes to the new line. Print, it doesn't go to the new line. It stays in the same line and prints. Okay, so we'll see the difference. what is the array elements? Array elements are like, okay, let us do this way. Array elements, keyboard of ints of counter. I just want space between each individual elements. Okay, that's why I gave that space. Okay, then we will say system.out.println. Please let me know if you are not able to hear me. It just gives another line. That's it. Okay. So let us try to execute this program. So here, as I have mentioned last time, still this particular program is executing. Okay, it's not terminated. The thread is still executing. So what we will give? We will give 5 elements. Okay, this is our input, 5 numbers. Okay. So what it does, it is accepting enter array elements. Okay, so it did not say anything. Okay, so 1, 2, 3, 4, 5. Okay, so it shows all the array elements 1, 2, 3, 4, 5. So the order in which I have entered, the index is assigned accordingly. Okay, 1 is 0, index I'm talking about. The index of 1 is 0, 2 is 1. So all these elements 5. Okay. So what we have done here is, so we are specifying how many elements we need in an array. Okay, how many elements we need in an array. Okay, using for loop, we are accepting the inputs from keyboard based on the number of elements. Okay, now we are printing here. After this, we are accepting and assigning. Not only accepting, we are assigning, accepting and assigning inputs from keyboard, the elements to be inputted and assigned. Okay, and then we are printing here, printing the array elements here. So it is a best practice to give these kinds of comments, at least brief comments. Okay, that is why we learned about these comments in one of our session. Okay, it is always advisable to give these kinds of comments. Okay, give these kinds of comments in your code. This helps the third person who in the future, right, who will be going through this particular code, right, he will be able to understand what is going on this particular code in a better way if you give the comments. Okay, that not only the third person. So say for example, you have coded this particular thing today, and after a month, if you want to open and see this code, you would have forgotten what logic you would have written. So it is also beneficial for us when we are referring to this particular code in future, or also for some other person who will be going through this in future, maybe an year down the line. Okay, so always it is advisable to give, or it is recommended to give these kinds of comments. Okay, it can be a single line comment or multi-line comment. Okay, so what we have done here, okay, so we have declared one array. We have seen how to assign an array element, how to assign values to array elements individually. Okay, and we have seen how to access the array element, individual array elements, using individual index 0, 1 and 2. Okay, and then what we have seen, we have declared another array and initialized it. We have not specified, note that we have not specified the size here. The size is implicitly assigned based on the number of elements you gave in your flower packets. Okay, while initializing how many number of elements you specify there, that size will be assigned to this particular array. Okay, so that can be kind of like we can display how many elements are there by using this particular dot length property of your array, any array for that matter. Okay, any type of array to be specific. Okay, So again, we are trying to access one particular array element using the index directly, not without any variables. Okay. The third way is we are accepting the input from keyboard and assigning the values that we accept from the keyboard to the array elements. Okay. The number of array elements we accept in a separate variable. Okay. And then we are assigning those things to individual array elements. So here what you can do is you have this array elements, right? You can also do this way. Okay. So just for your reference, I'm telling. Okay. This way also you can do it. What is the advantage of using this way? We don't have to declare this particular variable. Okay. So that means you are saving 4 bytes here, because this is an integer. We are saving 4 bytes with this particular statement. Okay. With this particular statement, we are saving 4 bytes. Okay. So what is happening? Whatever the value that you enter, that will be assigned as the size of this particular array. Okay. It can be done with this way also. Okay. So now we are accepting individual array elements values, whatever the value that we enter from keyboard, we are assigning it to respective index in keyboard ints array. Okay. Then we are displaying it. Okay. So till now we have done some basics of array. Okay. So please let me know if you have any questions till now. So I'll wait for a couple of minutes. If anyone has any questions, please let me know. So tell me, how many of you are practicing whatever we discuss in class? How many of you are discussing? I know few people are sending emails to me with their doubts. Okay. So I will reply to Kolari. Yeah, Hari is practicing. So did you get any issues, like apart from the things that you discussed? Did you get any other? Yes, practicing. Okay, Tina is practicing. Cool. Anyone else? I know Hari, Pawan, and few more people are practicing because they are sending their doubts. Yeah, good, Abid. So they are sending. I didn't know how to give array size with keyboard. Cool. Yeah. So good. Yeah, Hari understood how to give size of the array from the keyboard. Now with this example, he is very comfortable now. So that's what I wanted is, I want all of you to, these may be very, very basic programs. I am doing these basic programs to make you all understand what exactly is going on. Whatever the topics that we have discussed, right? You can see all those things being used here, except for the 2-dimensional arrays. Okay, except for 2-dimensional arrays, and I'm discussing only single-dimensional array here. That is why I'm just using single-dimensional arrays here. Okay. Please let me know if you have any doubts regarding this. Did you all understand what exactly is going on here? Okay. Did you all understand what exactly is going on here? Okay. Hugh says, yeah, he understood. Only Hugh understood. Anyone else? Anyone else understood whatever we discussed so far? Cool, Neha. Yeah, Neha understood. So I want, even if you have any doubt, right? Even if it is, even if you think like it is very simple or silly doubt, please tell me so that we can clear it then and there itself. Okay. So I want all of you to understand whatever we discuss clearly. And the main purpose of last class and this class is to make sure that whatever the concepts that we understood, how to implement whatever the concepts that we have understood. Okay, so the concepts we might know. We think that whatever the topics that we discuss in class, right? You may think that you are fine with that concepts, but the main thing with the learning programming is you have to practice it. You have to implement whatever the concepts that you learn in your sessions. Okay, I keep on telling the same point again and again, just to emphasize that you have to practice. Then only, or you have to whatever the concepts you learn, try to put it in program. Put it in a program. Test it. Test your knowledge. Whatever the knowledge that you gain from session, test it. Okay, then only you will get a better understanding of your sessions. Okay, whatever you understand. Okay, so this is one example, some basics of yeah, Avid has a question. I'll come to you, Avid. Just give me a couple of minutes. Okay, this is the basics of single dimensional array. Yesterday we saw a few basics of basics of variables, all those stuff, right? Yeah, so let me take up Avid's question. So okay, so Abid's question is he's still confused. Okay, so not exactly confused, he has a doubt. So he's still asking question, why we declare, I still did not get why we write public before a class declaration. Okay, public, this is the question he's asking. I did not get why did we write public before the class declaration. So this is the public we are giving, right? This is the public we are giving here. Okay, so why we are giving public here? So does this code work without the public? Let us see. Yeah, it works. Okay, it works. I will give one. So it works. So I gave this, it worked. Okay, so we have seen that there are something, yeah, it is the default class. Exactly here, correct. It is not the default class, the access specifier, right? We have different kinds of access specifiers. Okay, so access specifier says to whom and all this particular class, or who or all can use the code within this particular class. Okay, that again depends on the members, what access you give to each and every member of your class. Okay, so if you don't specify any access specifier, right? If you don't specify any access specifier, it is called as package level access. Okay, package level access. By default, that is the access level to a class. Package level access means we have declared on package here, right? Session 15. Any class that you declare within this particular package, that class can access this class. But outside of this particular package, say for example, if I have a session 14 package, those class cannot access this particular package. Okay. Okay, Abhid is again asking. So we will discuss all these things when we go to class and when we try to explore more and more. Okay. As of now, let us stick to this particular syntax. Okay, public class. Okay, let us stick to this particular syntax. I don't want to confuse everything. Okay, but as I keep on telling, like there are people who are kind of like learning all these things for the first time. Okay, let us not try to confuse them with too many things at a time. That is the only objective. So this is, let us stick to this particular syntax as of now, public class. Okay, so that if you don't specify public, it will become default access specifier. Okay, so otherwise opposite of public is your private. Okay, so we'll discuss. There are 4 access specifiers for a particular class, or for that matter any member of a class, including the class. Okay, so we will see all those things when we discuss about the classes and their properties. Okay, is it mandatory to write it in every program? So Abhid is asking the question, is it mandatory to write public for each program? So it is not necessary. That is why we have different access specifiers. mainly public, private, and default. Okay, default we don't specify any keyword. Here public is a keyword, Java keyword. Okay, private is also a Java keyword, and default is also default. We don't specify. Default doesn't have any keyword. Okay, so Java keyword we are using right now is public. Okay, private means nobody can access that particular class. Okay, that is the private. So let us discuss those things in future classes. Okay, so we have seen. Cool. Yeah, thanks, Abhi. Yeah, we have seen how to accept declare array, give size explicitly. Okay, and how implicitly how the size of an array we are talking only about single dimensional arrays. Give me a second. Okay, so we have implicitly declared the size of an array by initializing the array while declaring itself. Okay, this is what is the second type. And then how to accept an integer from command prompt and assign that integer to declare the size of an array. This is how it is done here. Okay, so how to accept the individual array elements using for loop. This is the way. How to display the array elements. This is the way. Okay, so please let me know if you have any questions. Now we will move on to what is known as the sorting. Okay, so one particular algorithm we will see, that is bubble sort. So we'll see why that is called bubble sort. There are many ways of sorting array elements. Okay, so you can Google it and you can try to understand the logic. I will try to give you the logic for bubble sort. You can Google it and you can find out what are the other search algorithms that are available for sorting an array element. Okay, so let us go and discuss what is a bubble sort. Okay, let me keep it here itself. Okay. Let us erase everything here. Okay, let's go to the next slide. Okay, so we will talk about what is called as we will discuss about what is called as bubble sort. Okay, bubble sort. So what is this sorting? We will take an array, swapping. So Kavita is telling it is swapping. Yeah, sorting is not swapping. Kavita, I know what you meant, but sorting is not swapping. So say assume we have an array. Okay. So Kavita is telling it is swapping. So sorting. Yeah, sorting in ascending or descending order. That is correct, but not swapping, right? So swapping you do, yeah, correct, Hari. Make an order, exactly. So Abid is telling, yeah, arranging in ascending or descending order, exactly, Abid. Yeah. So we assume that we have 5 elements. Okay, 9, 5, 7, 3, and 1. Okay, this is an array A of 5 elements. Okay, I want it in. Okay, note that this is 0, 1, 2, 3, and 4. Index. These are index. Okay, index of each element. Okay, so now I want it in this order. 1, 2, 3, 4. 1, 3, 5, 7, and 9. This is in this way. It's an ascending order, right? 1, 3, 5, 7, and 9. Okay. 1, 3, 5, 7, and 9 is ascending order. we will see one logic for one particular way of ordering, that is ascending. Okay, you can try for descending order. So it should be descending. This is ascending. Yes, ascending. So descending will be 9, 7, 5, 3, 1. Okay, this is descending. Okay, so this is descending, right? 9, 7, 5, 3, 1. So how to achieve this particular thing? Let us see. Okay, and let us try to elaborately discuss about the logic of bubble sort. Okay, so again we have the same number of elements. 1, 2, 3, 4, 5. Okay, 9, 5, 7, 3, and 1. 0, 1, 2, 3, 4. So what Kavita was telling, she was telling it is swapping, right? So let us see what is what she meant. Okay, so what we are doing, we are trying to arrange the elements of an array in ascending order. A, F, C. I'll mention it as A, C for ascending. Okay, so what we have to do, we have to compare this element with this element. Okay, then we have to compare this element with this element. Then we have to compare this element with this element. Then we have to compare this element with this element. Okay, so assume that we are comparing the same element. So assume that how many number of comparisons at least that we need? We need maximum of 1, 2, 3, 4, 5 comparisons. Okay, 5 comparisons. Including the same number comparison. Okay, okay, here. Yeah, we will come to that one here. Yeah, n square we will see, n square we will see that one. Okay, so for simple to explain this logic simply, I'll try to take some time and explain it. Okay, so that it is understood to everyone. Okay, okay, here. Yeah, so minimum or maximum comparisons that we need is 5. So assume that we have taken n as number of elements. So the number of comparisons is n. Max comparisons that is needed is n. Okay, so let us try to do this one by one. Okay, first what we will do, how is the number? Number is 9. I have put it instead of horizontal. I'm taking it as I am taking all the numbers in vertical manner so that it is easier for me to compare. Okay, I'll compare these two things, 9 and 5, which is lesser. 5 is less. So what I will do, I will swap 0, 1, 2, 3, 4. These are all our indices or indexes. Okay, 5 and 9. Now this becomes 5, 9, 7, 3, and 1. Okay, next what I will do, I will go to the next element. I'll compare these two things. Okay, so now it becomes, which is greater. We will push that to down. Okay, so now it becomes 5, 7, 9, 3, 1. Okay, next we will go to, this is the 0th element, this is the first element. Okay, this is the third element. Okay, we will compare these two things. Okay, you have to notify it, notice each and everything, whatever is happening. Okay, so now which is greater, we'll push it down. Okay, 5, 7, 3, 9, and 1. Okay, so this is the first comparison of all the elements within your array. Okay, so what I will do again, compare these two things. Okay, what happens? 1, 5, 7, 3, 9, so 3, 1, and 9. Okay, so first this is done. At the end of first comparison of all the elements, individual elements, right? What we get? The largest element. Okay, the largest element is pushed to the last index. So this becomes index of the array is, the last index of array is 4 for 5 element array. So the largest value is pushed down to the last index here for this particular requirement, that is ascending order. Okay, so now we need not have to worry about this one. We need not have to worry about this particular comparison. Okay, so what has happened earlier, 9 was at the top, which is the largest number. Okay, so for after first comparison, it came down to from 0th index to first index. Second comparison, second index. Third comparison, third index. Fourth comparison, it reached its position, that is the largest position. So what we are saying is it is bubbling down. Okay, the largest number is bubbling down, and it after all the comparisons are done, it reached its position. Okay, it reached its position. Okay, now this is for first pass through all the elements. First pass through all the elements, or we can call it as for first iteration. Okay, for first iteration. So let us see for second iteration. We have not completed our order, right? So it is still not in proper order. Okay, so now we will see what is the elements that we have: 5, 7, 3, 1, 9. Okay, now we will compare this with this. Okay, we need not have to swap because 5 is already on the top, lesser number is already on the top, so 7 is here. So next what happens? 5, 7, 3, 1, 9. So I will compare 7 with 3. Okay, we have to swap because 3 is lower and 7 is upper, higher. Okay, 3, 7, 1, 9. So I will compare with these two things. Okay, now it becomes 5, 3, 1, 7, 9. Okay, next we need not have to compare because this is the largest number we got after first iteration, right? So we need not have to compare this one. So number of comparisons here is 4. Number of comparisons here is 1, 2, 3. Okay, number of comparisons. This matters. Okay, number of comparisons is 3. Okay, so let's see now what is the element that the order of elements is 5, 3, 1, 7, and 9. Okay, let us go to next slide. Okay, so what we have is elements that we have is after second iteration, third iteration, what are the values that we have? 5. What are the values that we have? 9, 5, 7, 3, 1, right? So now we had 9 and 7, 5, 3, 1, I guess. Okay, 5, 3, 1, 7, and 9. Okay, let me write it this way: 5, 3, 1, 7, and 9. Okay, so for first iteration, 4 comps, that is comparison. Second iteration, we had 3 comparisons. Okay, this is third iteration. Let us see how many. So we have got our first largest element and the second largest element. Okay, in the respective indexes. So how many comparisons that we have? 1 and 2. Okay, so for third we have 2 comps, comparisons. Okay, so what we do, first we compare with okay, first we compare 5 with 3. So we will swap it. 3 and 5 and 1, 7 and 9 are just like that. Okay, and then we compare with these two things. So what happens? Now we got 3, 1, 5, 7, and 9. Okay, I'll see that after third iteration. This is third iteration. Okay, so we got 3 largest element, 9, 7. Okay, now for the fourth iteration, what do we have? How many comparisons? Only one. So 3, 1, 5, 7, 9 are there. Now I will compare these two things. 1, 3, 5, 7, and 9. So for the fourth iteration, how many comparisons I have? Only one comparison. Only one comparison. So can I put this in an equation? Can I put this in an equation? Can I put this in an equation? So whatever we have discussed, okay, did everyone understand this logic, whatever we have discussed just now? Did everyone understand this logic? Please let me know. Yes, Subhi understood. Subhi Regi understood. Who else understood? Or who did not understand? If you want me to explain it again, we will explain it again. Yeah, Hugh has a myself. Okay, Abid understood, Neha understood, Tina understood, Kavita understood, Hugh. Oh yeah, Hugh. Give me a second. Okay, let me finish this here, and I'll give you an opportunity to explain your logic. Okay, so your logic may be better. Okay, we will see that. This is just for all of us to understand. It is that's why I've kind of like simply explained it. Okay, to make it simpler. That's it. Okay, so we can put it. Did you? Okay, let me ask you a question here. So what he was telling is this is the logic which he is telling. Yeah, how did you come to this particular logic? Did you try this particular logic for bubble sort? You can speak. Yeah, seems like I'm not sure whether you are talking on mute. I have unmuted you. You can speak here. Okay, fine. Okay, fine. No worries. Okay, so whether can we put this particular logic into our? Yeah, hold on. I'll unmute you. Okay, I thought. Okay, so I have unmuted you. You can speak. You can speak. Yeah, you can speak. Yeah, you can explain whatever the logic that you have or the equation that you came across for bubble sort. I'm not sure whether you're speaking. No, we are not able to hear you. We are not able to hear you. Oh, okay. We're not. Is anyone able to hear Hugh speaking? So looks like you're on mute. Hugh, can you just check whether you're on mute? Yeah, I think now we can hear it.
Okay.
Yeah.
Okay. Are you guys hearing me? If you look at the comparisons, every time let's say you started with 9 and you compare until 9 became the largest number, and
correct.
When you take 5, 5 would be -1 the number of time 9 was compared, and then the next number would be -1 the number of time 5 was compared, and so on and so forth.
Correct. So right, this is what you are telling. Right? This is the exact thing that I wanted to put. Yeah, exactly. That is your understanding is very correct here. That is correct. That's what I have mentioned it here. So I would, I mean, I wanted to give this meaningful expression here. Yeah, whatever you told
Okay.
is exactly correct. Okay, thanks a lot to you. Thank you very much.
Okay. You're welcome.
Yeah. So that is what I was telling is, can we put this in a program or in a logic? Okay. So what we can say is, let us assume we have taken this. Let us take this one for this. Each iteration we will take one particular loop. Okay, for loop. Assume that it's for loop. So first iteration will go first, or we can say 0th iteration, first iteration, second iteration, third iteration, fourth iteration, like that. Okay, we'll go in that order. Okay, how many iterations? Max that we need is n iterations. Okay, or n minus 1. Here we see 4 iterations are there for 5 elements. So let us take n as a number of maximum number of iterations that we need. Okay, then for each iteration, what is happening? For first, we need 4 comparisons. For second iteration, we need 3 comparisons. For third iteration, we need 2 comparisons. For fourth iteration, we need 1 comparison. For fifth iteration, we need 0 comparisons. Okay. So max iteration is, let us assume it is n. It is the number of elements. Okay. So n is our number of elements. Please excuse my handwriting. I am not getting time to practice it. So that's why it is still bad after a week of practice, if you can call so. Okay. So number of elements is n. So number of iterations that we need is, maximum number of iterations that we need is n. Okay. So let us assume n iterations that we need. So for first iteration, what we had? 4 comparisons, taking n as 5. Okay. For n is equal to 5, 4 iterations. So can we express this 4 in terms of n? We can express n minus 1. Right. For second iteration, how many comparisons that we need? 3. Can we express in this in terms of n minus 2? Okay. For third, 2 iterations, right? N minus 3. For fourth, 1. N minus 4. Okay. Fifth iteration, 0. N minus n, 0. Okay. So you see here, this is changing. Okay. But this is remaining constant. So this is what? This is the number of elements. Okay. This is the comparison or the iteration. Okay. So assume for 5 elements, maximum number of comparisons that we need is 5. For 6 iterations. Okay. 7 iterations. For n number of elements, n iterations. Okay. N iterations. So assuming this one, let us write, assuming this, let us write this one. Yeah, Kavita is saying no, this is not proper. So, okay, let us try to do this one first, and afterwards we will listen to you, Kavita. Okay. So whatever the doubts you have, or wherever you have doubts, you can, I mean, wherever I am going wrong, you can correct me. Okay. So for number of iterations, we can say, we can take one particular loop, and for comparison of 2 numbers, we are taking comparisons, right? We will take another loop. Okay. And then we will see how that goes. Okay. For, okay, I won't mention data type and all, just I'll mention first one, 0. Okay. So how many number of comparisons that we need? N, you can give n minus 1 also. Okay. So let us see. Okay, why that is n minus 1? We will see. We will take it as n. Okay, Kavita wants to explain that one. We will listen to her. Okay, plus. Okay. Then another loop. What we will do in this loop is, this is for our iterations. Okay, this outer loop is for our iteration. Okay, let us take another loop that is for our comparisons. Okay, j is equal to 0. I don't mention the data types. J less than some expression. Okay, and j plus plus. Okay, let us make this 1. We will take it from 1, and then we will do it. Okay. Oh, okay, okay. Sorry, Kavita. So I'll give you an expression to. I'll give you an opportunity to explain your. No, okay. So are you able to hear me, Kavita? Okay. Yeah, whatever I explained, right? The same thing he also explained. So for first iteration, he told it in expression. Before I gave you the expression, he told it in expression, the same expression which I explained. Okay. So what exactly we are doing? So this is the loop which we use for comparing individual elements in an array. Okay. So what we do? We start with index 1, and this is very important. This part and this part. This is very, very important. Okay. This part is very, very important. Based on the logic that we discussed, these things come into picture. Okay. So let me write that expression again. Okay. First iteration we have, let us consider 5 elements. Okay. First iteration we have I is equal to, for first iteration we have 4 comparisons, that is n minus 1. Second, 3, n minus 2. Third, 2, n minus 3. Fourth, we have 1 comparisons, n minus 4. Okay. So you see, this is what is this. This is this. This is this. This is this. Okay. So if we take this iterations here as I, so what should be our expression here? N minus I, j plus this. Okay. Did everyone understand this? Did everyone understand this logic? Did everyone understand? Yeah, Abid understood. Okay. So this is the logic for your comparison. Okay. So how many for each iteration? This is the number of passes in your array or iterations. Okay, we call it as iterations. For each iteration, how many number of comparisons that we get? We get this many number of comparisons. This is an expression. Okay, what we are doing? Declare one integer, temporary integer. Okay, temp. Okay, so what we will do? We will check whether some array, say array A, I have declared array A. Okay, if A of 1, A of j, that is 1, that is our 9, 5, 7, 3, 1. Okay, so what I'm doing, I'm comparing this with this 1 and 0. If A of j is 1 greater than 9, A of j minus 1, is it greater than j minus 1? If it is greater than j minus 1, I won't do anything. This is greater than this. Okay, so I won't do anything. But if it is A of j is less than j of this one, I will swap it. Okay, temp. What I will do, I will put this value. Oh, sorry. Okay, thank God it is there. Okay, I will assign this value to temp, and then I will assign this value to this. I will assign this value to this. Okay, temp is A of j, A of j is A of j minus 1. So I have assigned it, right? A of j is temp. Oh, sorry. A of j minus 1. So you can verify these statements. Okay. So this is how you do it. Okay, once everything is done, all the loops are done, the elements will be arranged in respective order, or you can give this way. Okay, whichever the way you want to do it, ascending or descending, it depends on this particular expression. Okay, whether it is greater than or smaller than. Okay, a of j is this one, a of j minus 1 is this one. We are checking whether this is greater than this. Okay, if this is greater than this, we won't swap. Okay, if this is greater than this element, we will swap. Okay, so we have to swap here. Okay, this is a temp is a of j minus 1. Okay, a of j minus 1 is a of j. A of j is temp. Okay, that's what you are doing for ascending order. Okay, so let me write it in a proper way. You can write all of, you can try to write this particular logic. Okay, so let me go to the next one. So what I am doing for int I is equal to 0, I less than n, I plus plus. Okay, for j, this is 0 is equal to 1, this is also int, j less than n minus I. This is the this one here. Okay, j plus plus. Okay, then we take a temp 1 is equal to, oh sorry, if condition a of j is greater than a of j minus 1, temp is equal to a of j minus 1, a of j is equal to sorry, what was that, 9 and 7, 9 and 5, right, j minus 1 j. Okay, temp is a of this one is a copy, j minus 1, that is 9, and then a of j, we are losing a of j. Temp, we will, what we will do, a of j we will take, a of j minus 1. Okay, I'm getting confused. Okay, so you try this example. Okay, you try this particular example, whatever we discussed just a few minutes back. Just try that example and see whether you can do it. Otherwise, we will see in our next session. Okay, and in next session we will continue with from where we have left. That is, we wanted to cover one particular operator, that is bitwise operators. Okay, we will continue with bitwise operators, and then we will discuss with this bubble sort. Okay, if you have any other sorts, there are a number of sorting algorithms. Just go through other sorting algorithms. If anyone wants to discuss that particular sort, whichever you found interesting, if you want to discuss that particular sorting algorithm, please let me know. We will kind of like start with that particular discussion, and then take up our session. Okay, or if you want, usually I log in around 10-15 minutes earlier than the session. If the session is scheduled at 8, I will log in at around 7:45 or 7:50, at the max 7:50. Okay, so that is during that time we can just try to discuss. Okay, Kavita has a question. Yeah, Kavita, please tell me. Do you have a question, Kavita? Kavita, do you have a question? Do you have any question, Kavita? Yeah, I have unmuted you. Please speak. Okay, you can speak. Or you can type, Kavita. No worries, you can type. You can put it in chat, Kavita. Whatever the questions you have, right, you can put it in chat. Don't have any doubt, Kavita? Yeah, you can type in the chat. Talking, I don't know. Okay, so let me unmute you. Yeah, okay. You can talk now, Kavita. You can talk now. Please ask your question. Yeah, we are not able to hear you. Are you speaking on mute? Please unmute yourself before asking the question, before asking your doubt. So we're still not able to hear you. Or what you can do is you can type that question in chat. Please type your question in chat. We will discuss on that. Please type it, Kavita. I'm waiting for Kavita to complete her question or doubt. We will discuss on her doubt and then we will conclude this session, okay? Yeah, Hari has asked one question and Pawan has asked one question. So I have replied to your emails, Hari and Pawan. Please look into that one and reply back to me, okay? Looks like Pawan is not there in today's session. Yeah, thanks, Hari. Yeah. Yeah, Kavita. Kavita is asking this particular logic. Okay, Kavita is asking about this particular logic. So we are comparing E of j with E of j minus 1, right? We are comparing with E of j. All these things, right? All this expression depends on your these things. So Kavita is asking why can't we use A of j greater than A of j plus 1? Why can't we use this way? Okay. Why can't we use this way? Instead of A of j greater than A of j minus 1. See here I have initialized this 1, initialize this as 1. So that is why this expression comes. So think what you have to initialize here for this expression. Okay, think what you have to initialize here for this expression and think whether any changes happen for these things. Okay, that is, you have to think. Okay, when you get a question, you just try to think. Okay, yeah, you try that one, Kavita. You try that one. Whatever you have discussed, whatever you are trying to tell, right? Try to implement that. Yeah, there are. What I'm telling is, this is not the only way. Whatever I'm telling, right? That is not the only way of implementing this bubble sort. Okay, I'm not telling this is the efficient way of implementing the bubble sort. Whatever we have discussed, this is just to explain the logic behind your bubble sort. Okay, so this is what I have given you. Okay, it need not be efficient. Whatever I gave you that logic, right, or algorithm, whatever I gave you, that may not be the efficient way of doing it. That is for bubble sort. There may be n number of ways in which you can implement one particular algorithm. Okay, n number of ways. One particular logic you can implement it in n number of ways. Okay, this is one of the way. Whatever you are telling is, that is another way. Okay, so that depends on like whatever the expression that you arrive, right? This is what she is asking. So whatever you are telling, right? So that depends on what you select here. this one, and this one. Okay, all these things, it depends on all these things. See, if whatever I told is wrong, please let me know. We'll try to correct in our next class. Okay, we'll try to correct in our next class. Okay, try to write the program with the logic that you have, that you are telling. I'll go through that logic. Okay, and I'll try to see where I went wrong. Okay, Kavita? Okay, so with this we will conclude the session, and we'll meet tomorrow at 8 p.m. CT at the same time. Okay, we'll start the session at 8:05 as usual. Okay, we'll continue with the, first we will cover bitwise operators, and then we will see the implementation part. Okay, if Kavita wants to explain this, we can allow her to explain. Yeah, thanks everyone. Have a great evening. Enjoy your evening. Bye.